Okay, we're going to finish up our chemistry unit. This is the last bit of chemistry, and then you're going to have quite a lengthy review to do, and then a culminating assignment / test to finish up the unit. And then we're going to be moving on to physics. So you guys have done a great job through this unit. I've seen lots of really good indications that you're understanding what you're doing, which is awesome. So we're going to finish up with something called neutralization reactions. And of course, this component is fun as well to do lab work with, which we are sadly without the ability to do. So one thing we do use in labs when we're trying to see if things are acidic or basic are these things called indicators. So indicators chemically react with acids or bases, and when they do, they change color. And the color they change tells us the level of acidity or how basic alkalinity the substance is. So this one is an example of an indicator I like to use, which is called universal indicator. And it changes color according to how acidic or basic the solution is. And it's not even showing you all the colors there. It goes right to this really dark purpley blue color. We also have other indicators. Red cabbage is one. Bromothiamyl blue is another. You can make indicators. I've actually brought into class flower petals and squished them up, and especially petunias make good indicators for level of acidity. So again, indicators are something we use in lab. Good to know they exist. Unfortunately, we're not going to be able to actually utilize any. So we are looking at today at neutralization reactions. So neutralization reactions happen when an acid reacts with a base. So if you are highly acidic and you add a base, it will move the solution towards 7. Remember, so 7 is neutral. If you're too acidic and you add an acid, again, it will move the pH towards neutral. And neutralization reactions are called double displacement reactions. So here's one we always do in class because it's just gives such a nice product. So we mix hydrochloric acid. So here's just your token example of the neutralization reaction. We mix hydrochloric acid with sodium hydroxide. And remember from our previous notes, you can recognize an acid because it will start with H. This is a binary acid, right? Just 2 elements, one being hydrogen. And then the base here, it's the hydroxide that tells you it's a base. So if we mix hydrochloric acid and sodium hydroxide, hopefully you understand a double displacement will mean these two will switch place. But we actually end up with these products. So that will give us water and salt. So the two products, and this is confusing. I guess they're just showing you here that the HOH. You don't need to write HOH. So what essentially happens is the sodium combines with the chlorine, right? Giving you sodium chloride, which happens to also be table salt. It's the stuff you have on your table. But not all, when they say salt here, an acid and base gives you water and salt. They don't mean you're always going to get table salt. A salt is what you get when you combine the two resulting anions, and the cation and the anion together. So the sodium and the chlorine ions will come together to form what is called a salt. So it's just by chance that this one happens to be table salt. And that leaves you with HOH, which when we look at HOH, that's a terrible H, is just H2O. Okay, so if the result, if you mix an acid with a base and your result is water, well, water is neutral or has a pH of 7. So in essence, you're neutralizing, right? If something's acidic, it has a lot of hydrogen ions floating around. But if you add hydroxide, the hydroxide will combine with the free hydrogen ions and you will get H2O, water. So that's in essence how we do a neutralization reaction. So maybe, just get rid of this in your note. And it's confusing. I don't know why it's in here. So just put hydrochloric acid plus sodium hydroxide gives you water, and then in this case, table salt. So a couple examples here. Well, this is the one we just did. Here's a different one where, again, you can look and say, okay, this is sulfuric acid, and go back to how we name acids. Remember, this is what we call an oxyacid. It's hydrogen combined with a polyatomic, and we ick the ending. So that's sulfuric acid. And we can recognize it by the hydrogen out front. And then potassium hydroxide, that tells us that's a base. The hydroxide tells us we have an acid. And when we combine that, the hydroxide and the hydrogen will combine to form water. And we end up with potassium sulfate, which is the cation and the anion will combine. And so in this case, this is called a salt. Okay. So basically what you have to remember is the hydrogen ions from the acid and the hydroxide ions from the base. What they're going to do is they're going to separate themselves from whatever they're combined with, and then they will combine with each other, giving you H2O. Okay, and whatever is left will join together. So what is a salt? A combination of positive and negative ions formed by the reaction of an acid and a base. So again, that's those cations and anions, and we don't always mean table salt, although, table salt, NaCl, is an excellent example of a neutralization reaction result when we combine hydrochloric acid and sodium hydroxide. So you can read through, I've attached the PowerPoint. You can read through how we apply neutralization reactions, some interesting information in there. And it shows how, how the chemistry worked behind that neutralization reaction. There's a nice little video here on heartburn, which is another application of neutralization reactions. So if you ever get heartburn, we discussed this in our biology unit. We know that there's hydrochloric acid here in your stomach, and you have this lovely LES, lower esophageal sphincter, that is located at the, top of your stomach, so that once your food mixes with the hydrochloric acid, it is not supposed to come back up in this direction because now it's highly acidic. However, if that little valve there isn't working, or if you're producing too much stomach acid, maybe you're really stressed, or you just ate so much that muscle just cannot keep the food where it's supposed to be, especially if you eat a big meal and then lay down, so gravity isn't pulling down anymore, you can get something called heartburn. And that is literally acid going up your esophagus and chemically burning your esophagus. So no different from a burn from hot water, except it's caused by chemicals. So you're chemically damaging and burning the inside of your esophagus. And there's, all kinds of symptoms associated with that. It feels like some people think it feels like a heart attack. You get burning in your chest, a lot of burping and feeling gassy and pain, like a burning feeling. So, just understanding heartburn. So if people who experience heartburn, they take an antacid to neutralize the acid that's already in their stomach, so that if it ends up coming back up the esophagus, well, it's neutral, so it's not going to burn. It's more like water with a nice pH of 7 that isn't going to be too acidic and burn the esophagus. So if you recall from our last lesson there on acids and bases, hydrochloric acid has a pH of 1.5, which is strongly acidic. They use the word discomfort. I love that word. Causes discomfort. It causes pain. Like it can feel a little uncomfortable for some people. It can be very, very painful. So what we do is we take antacids, and one of the most common antacids is magnesium hydroxide. So there you say, oh, there's my base right there. And if I mix it with the hydrogen and hydrochloric acid, well, I'm going to get water. And water is, a lot more friendly if should it not be held in the stomach and it should it come up the esophagus. A lot more friendly than the hydrochloric acid on its own. So when you pop a Tums or a Rolaids or a milk of magnesia or any of those other ones, you are actually neutralizing the acid in your stomach.